This is day 2 of me designing Climbot. So today I decided to go over how rope dynamics will work with Climbot. When a person falls off a cliff and they have a 5-meter gap between their quick draws, they end up falling 10 meters actually. So first we must find the energy in this fall, which is simply mass times gravity times height, which ends up being 8 kilojoules. So, like I said before, I want to analyze Climbot as it is a static system, which means that nothing will move. So, we have 8 kilojoules of force pulling up on the arm. Just knowing from intuition, pulling up on an arm that is extending out is going to cause a torque. This means that we are eventually going to need to solve for this rotational force and how the system is going to be stabilized. I decided to simplify the arm down so that it's just essentially a cantilever beam. So we have a rope that is pulling up with a tension at a degree of, say, 80 degrees if the Climbot is positioned properly to the wall, and we have a resistive force of this cantilever beam in both the y and x direction. So the rope stretches to about 37%, which means that it'll stretch 3.7 meters as the person falls. Hooke's law states that work is equal to 1/2 force times distance. So we plug in work, or our energy, and we can solve for force, which ends up being 4.32 kilonewtons. We can then split this up into its y into its x. 4.25 kilonewtons of force acting in the y direction, 0.75 kilonewtons acting in the straight x direction. Now we can solve for the resistive forces in the x direction is negative 0.75 kilonewtons, and the resistive force in the y direction is negative 3.47 kilonewtons. Okay, so now that we know the forces acting on the beam, the initial tension, let's go down to solve for the static anchors. When solving it, I found out that this system is statically indeterminate. And this is because this system has 3 anchors, and we are only given 1 force of tension. When breaking up this 1 force of tension, you can only get 2 components. Now, when solving for a system, you cannot solve all 3 of these variables with only 2 components. So that's just what makes it indeterminate algebraically. There's no advanced physics going on. So in order to solve it further, I would need to expand it out into a 3-dimensional plane and solve it on pen and paper, or I would need to use a 3-dimensional simulation software. So this is day 2 of brainstorming Climbot, going over rope dynamics. Thanks for watching.